we need to solve over here is that we need to predict the percentage of a student based on the number of study hours. So the data can be found, which we need to train on the model, is this link, and this is the link, and here are the hours. 2.5 hours a student studied and its score was 21. 5.1 hours the score was 47. So we need to then answer the question that what will be the predicted score of a student studies for 9.25 hours a day. So first of all, we need we defined a URL which stores the data. The URL points to the link which contains the CSV file hosted remotely. So this is the CSV file, which is, and we have stored it in a data, and then we load it, and we can see that the data has an data.head. We can print the data and we can see the 10 rows of it. How it happened was that pandas sent a HTTP request and then to the server. The server then responds with the CSV data. CSV data then gets towards Panda. Then let's find the relationship between the data by plotting. So we plot the data, and then Panda decodes the CSV file, detects the commas and reads line by line, and then it stores in the data frame. Now this data has the data frame. You need to remember this, that whenever we use it, that data is having all the values which is over here. So data dot plot, and then we give the x-axis the value of hours, the hours column, and then the y gets the scores column. The scatter plot suggests that as study hours increase, scores also tend to increase from the graph. Now what we will see that the data has the data set, and the data set has iLoc. iLoc is locates the rows and columns of the data. The data sets iLoc locates rows and columns. So colon means over here that all rows. I will be showing you from all rows will be selected, and it says that all rows and all the columns, that colon means all the columns except -1 means except the last one. So we will be having all the columns except for the last one. The scores won't be included and R will be included. Now if I see for Y, it says all rows, so all rows and the first column. So all rows and first column, what it will mean that all rows and the first column. This is the 0th column, so this won't be selected. This scores column of B, this will be selected. So this is, then we will be doing a train test split. How we will be splitting it? Through the trained sklearn model selection, and test size is 20% of the data. So X, which is having the R section, R's column, will be splitted further into train and test. So and test size will be 20%. So R's test is this, X is this, and the test size is 20%. For example, we will be choosing, the model will be choosing randomly. For example, this is the test size. Okay, so this, the other is the training size. Same for the Y. Y will be having test size this one, and Y train will be this one. We create a linear regression object. This from the sklearn model we have a linear regression, and it has been assigned to regressor, and regressor fits it. How it works is through the gradient descent method. How it initializes the weight for R's. Let's say 0.5 and bias is 10. So y is equals to mx plus c, and m is 0.5, which is the weight, and the bias is c, the y-intercept, which is 10. So we will be completing it, and 2.5 is the first data set, which is this one. This is 2.5. This is the R section. So we will be calculating the score. The score is 12.5, but actual score was 21. So there is 21 and 12.5. There is a 8.5 error. So what we'll be doing it, we will be adjusting the weight and the biases again and again and again. For example, now we have the weight which is M is 9.9 now, for example, and C is, for example, 2.018 now. So if error gets negligible, then this would be the regression line equation with the M as 9.9 and C as 2.018. So this is how it works. Now we have the line equation which is 9.91 x plus 2.01. This is the line equation, and for example at 9.9 as the gradient and 2.018 as the intercept, our error gets negligible. For first, our error was 8.5 when we subtracted the R score and the actual score. Our predicted score and actual score, the error was 8.5. Now what we will be doing is we will again be calculating the error again and again and again until it gets into very less value. Now from this line equation, which is 9.9 x plus 2.018, we feed in the x test data. X test data is, for example, it has y is equals to x test has 1.5, so it will be 9.9 and then 1.5 plus 2.018. It gives us 16.8 something. So this is C, this is what it gave, and actual it was 20. This you can see it at 1.5. We can see our own data by inputting 9.25. See, we will be doing the same thing again as we did for before, that it will be 9.9, which is the regression line equation, and 9.25 is the R studied x plus the bias, the y-intercept, which is 2.18, and this gives us 93.69.